Hello students, Jai Swaminarayan. This is Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Gandhinagar. I am the subject matter of Power System 2, which is in the 5th semester, and the subject code of this subject in GTU is 3150911. Students, in topic number 1, we studied about power in single phase AC circuit, and in topic number 2 we studied about the complex power flow and complex power balance. Now in topic number 3 we studied about balanced three phase circuit and three phase power. Now this is our topic number 4 of chapter number 1 of basic principle of PS2 is star delta transformation and per phase system. So whenever we analyze any three phase circuit, we need to convert any delta connected circuit, whether it is source or whether it is load, into the star connection, because it would be easy to calculate the line voltage as well as the phase voltage and line current as well as the phase current of the star connected network. Now in single phase equivalent circuit, generally it is used to calculate the line current and the phase voltage. So whenever we want to calculate the phase voltage, we must have to convert any delta connected circuit into the star, because we can take out neutral from the star circuit only. So once we know the line current and phase voltage in a phase equivalent circuit, so we can take the analytical shortcuts to find out the current or voltage in balanced three phase circuit. So first of all, what do you mean by delta? So delta is a, we can say, having three branches which are connected nose to tail, means uh, starting point to ending point, uh, uh, tail, and they form the triangular closed shape. So this configuration is referred as the delta. And in case of star, then connect the branches of, we can say, one point is common and either point is connected with the line. So common point of a star like pattern is known as the star connection. Now the star and delta connection can be transformed from one form to another form. For simplifying the complex network, delta to star or star to delta transformation. Generally, such kind of transformation is required to calculate the per phase voltage. So whenever we have such connection, means generally power transmit from the generating station through the delta transformer, and then after at the transmission line it will be then transmit again from the delta, and at the distribution system, that delta means received power from the delta will be further converted into the star, because consumers require three phase four wire system, or we can say we can give individual phase to the consumer. So that's why if we want to calculate that power, then we need to convert that delta connection into the star. Now this is a simple method to convert the star to delta transformation that we already studied. From this we can we will be conclude that how we convert delta connected load to the star equivalent star connected load, or delta connected source to the equivalent delta connected load. So from this simple equation, then from this with the help of this simple equation, we will calculate the delta to star and star to delta transformation. So first of all, we'll take the delta to star transformation. So this is the shape we say it is delta. Now this delta having three branches, R1, R2 and R3, that will be converted into RA, RB and RC. Means with terminal A the RA branch is connected, the terminal B RB is connected, and terminal C RC is connected. Now if you take this branch means A to B, then you can see that with this branch these two branches are in series, and or we can, these two are in series and this series branches are connected with AB is in parallel. So we can write this equation, these two are in series, so that's why it is R1 plus R3, and it is multiplied with R2. So divide by all three resistance of this AB, BC and CA branch. So R1 plus R2 plus R3. Similarly, we can write an equation for RBC and RCA. So these are the equation of all three branches. Now RAB is equal to, from here RAB is equal to, this is the series connection, so can we write RA plus RB, RBC is equal to RB plus RC, and RCA is equal to RC plus RA. Now here consider a delta system that's three corner points A, B, C are shown in the figure, and now we write the equation to convert this delta into the star in the next slide. So we are comparing both the sides of star as well as the delta. This is the star side and this one is the delta side. So RA plus RB is equal to, here you can see that RA plus RB. So what was the equation for first branch? RA is equal to R1 plus R3 into R2 divided by R1 plus R2 plus R3. Similarly, we can write all three equations for all three branches. Now by adding the above equation, we will get 2 times, means here we are editing the two equations, means three equations. So we will get 2 times RA, you can see over here, 2 times RB and 2 times RC. So 2 times RA, RB, RC means addition of this two, and if you simulate this 3, you will get 2 times R1 R2 R2 R3 R3 R1 R1 plus R2 plus R3. Now if you solve this, you will get RA plus RB plus RC is equal to this, and if you further simulate it, that if you further solve it, then you will get RA is equal to this term, first one, R1 into R2 is divided by 2 divided by R1 plus R2 plus R3. Similarly, RB is equal to this terms, R2 into R3 divided by R1 plus R2 plus R3. So similarly you can write all three equations. So from this we can find out RA, means in previous slide you can see that if we want to calculate this RA, then the equation of RA is equal to R1 into R2 divided by R1 plus R2 plus R3. Similarly RB, then R2 R3 divided by R1 plus R2 plus R3, and similarly RC, so R3 into R1 divided by R1 plus R2 plus R3. So this is how we can calculate the resistances of star connected branch. But if we put 1 ohm or having, means all the resistances are same, suppose, then RC will become 1 upon 3, means 1/3 of all the resistances. So from this we can calculate our power, means transformation from star to from delta to star with the help of this equation. We will see we will see the use of this equation in next consequent slides. Now by using this equation relation, we can find the resistance of star network, or we can find the, we can convert this into from delta to star, because we will take the clue from this. We will say, then we will say this in the next slide. Now this is the simple example which is given over here. Calculate this example, students, this is for you. Convert this from delta to star. All the, means answer of all the branch, means RA, RB and RC is given, and match it out from by calculating this equation. Now you can take the snap of this. Now from star to delta, now here you can see that A, B and C branch having resistances, A for A RA, for B RC RB and for C RC. Now equations for this branches is that we already derived. So these three are the equation of RA, RB and RC from the delta to star. Now this equation will use for the star to delta transformation. Now if we add all these resistances, means RA, RB, RC, so this will become, let us we can say manipulate all the above equation in order to get the resistance of delta to delta network. Means this RA will converted into R1, then RB is converted into the R2 and RC is converted into the R3. Now multiply each set of this two equations and then add, means multiply this two and then add. So Ra into Rb, then Rb into Rc, then Rc into Ra. So if you multiply and add this equation, you will get the final solution, that is RaRb plus RbRc plus RcRa is equal to multiplication of all the resistance of different branches and divide by all the resistance, means addition of the all the branches, means R1 plus R2 plus R3. So from this equation we can write the equation for R1. Now by dividing equation number 4, means previous equation, you can see that this is the previous equation. Divide this equation number 4 with equation 4 with 2. So the second equation, we are dividing this equation with the second equation, so our equation for the R1 will become RAB plus RBC plus RCA divided by RB, and the final equation for R1 is equal to RC, means resistance of either branch is RC plus R1, sorry, RA plus RC into RA divided by RB. Similarly we can write the equation for R2 as well as the R3. Now from this equation, if we put all the resistances having value same, means 1, then we can write the equation, means 1 plus 1 is equal to 2. Then the uh, now then if we replace this RA RB RC with 1 ohm resistance, then this will become 1 plus 1 means 2. Then this two are the 1, means 1 into 1 1, and this divide by 1, so it will be 1. So uh, 1 plus 1 then plus 1 means 3 times of mm, the branch of the star connection. So from this equations we will use that we already derive in the means lecture number 2, that transformation of star to delta and delta to star, means which we used that equations. So by using this equation and relation, we can find the resistance of delta network from the resistance of star network, or we can say, I mean, in this way we can convert the star network into the delta network. So this is again one example is given to transfer star into the delta, and these are the means answer is given of all the branches, means which you find from this. So uh, means you can take this as a reference and the above equations, and you can calculate star to delta transformation. Now we are recalling the previous lecture in that we converted star into the delta. This is the source transformation. So as we know that the first phase is as a reference, so that's why it is Vy means star voltage at theta y, then 120-degree phase shift between each of the phases. Then star to delta, if we calculate this, we will put the means simulation of this three, and we convert suppose VAN into VAB. So this phase voltage will be converted into the line voltage, so it will be for the delta connection, line voltage is equal to root 3 times the phase voltage, so that's why root 3 into Vy, but it is at 30-degree. Now similarly if we calculate all the VAB VBC and VCA, then VBC is minus 90-degree and VCA is minus 210, means 210 degrees. So this is how we can use this equations to transform star to delta. In this you can see that the line voltage is root 3 times. So in previous transformation we seen that it was 3 times to the impedance of or resistance of the particular branch. So here it is root 3 times Vy, and here you can see that from delta to star transformation, so it is V delta is at reference, means VAB at reference, that's why it is theta delta, and again 120-degree phase shift. And suppose we convert this from delta to star, then we'll get V delta, because each branch is having same means voltage, so the source which is given having same value, so that's why or we can say three phase balance source. So having all sources having same value, so that's why v delta divided by root 3 and it is 30 degree. Means if you solve this delta to star transformation, you will get the angle values that we already studied in the second lecture. Then vbn will be minus 150 and vcn will be minus 270. So from this we need to transform any delta connected circuit into the star for the per phase analysis. And for per phase analysis we require the line to phase voltage. Means that's why we require neutral. So that's why we convert delta connected circuit into the star connection with the help of such equations. Now this is the transformation of star delta for the balanced three phase load. Means in previous slide we studied about the sources, now this is the load. So as we already studied, the if the impedances of all branches are same and this is the balanced load, so that's why impedance of all the branches are same. So that's why we can write star connected impedance is 1/3 to the equivalent impedance. So in the star connection, and in the delta connection, the delta connected impedance means equivalent impedance of this delta connection is the 3 times to the star connected impedance. Okay, so this is how we can transform load and source into balance while it is balanced. So we can transform delta into star and star to delta as per our requirement to calculate the power and to analyze the circuit. Now per phase analysis. So basically per phase analysis we perform to we can say, since the neutral carries no current in balanced three phase circuit, so there is no current through the neutral because all the branches will neutralize the current. Means all the branches having same impedance, so that's why there is no current through neutral. So the current in the neutral of the star the balanced star connected load, and this is the source and this is the load, both are in star connection. So you can see that the first branch EAN and the impedance of this branch is ZZ. So for all the branches having same impedance, and this is the line impedance, so it is ZL for all the branches. Now when it is reaches at the load, so at that time you can see that the all the impedances of this branches are same. Means ZP and ZP. So at VAN will be converted for A to receiving, so that's why it is small a. So VAN to VAN, then VBN to VBN, then VCN to VCN, and neutral is connected with this link, and all the branches having current IA plus IB plus IC is equal to 0. So from this above figure, it is as it is balanced, so we can write neutral current IN is equal to IA plus IB plus IC is equal to 0. Now any other impedance including a short circuit and open circuit, we can say maybe replace with the impedance over here. Means neutral carries no current, so neutral wire of any impedance may be replaced by any other impedance including a short circuit. So here no current, so we indicated with the short circuit, there is no impedance between the line, and the neutral line may not actually exist, but here we drawn neutral is short circuited, so because it has a zero impedance, that's why. So we drawn over here with the single means only a line, there is no impedances and resistances drawn between these 2 points. So the balance power system problems are then solved the per phase basis, because this this neutral from the star connected we have the neutral, and from this neutral we can bifurcate, or we can say separate each of the phases. Means VAN, VBN and VCN we can calculate separately. Means all three branches or all three phases we can calculate separately with the help of star connected circuit. So if we have a delta connected source, then we need to convert that delta connected source into the star connected delta connected load into the star connected load. And for that we used delta to star transformation that we studied in the previous slide. Now it is understood that from this figure the two phases carry identical current except for the phase shift. If there is a phase shift, then we cannot take two phases identical, or having we cannot say that two phases carry identical current. So there is no phase shift, means A is connected with A, B is connected with B, and C is connected with C. So that's why for the per phase analysis here we taken only one phase, that is EA and VA to VA, and this is the line impedance, and this is the source impedance, and this is the load impedance. Now VAN indicates that it is the means load side voltage, or we can say phase voltage, which is in series with ZL ZP. It is shown in the diagram. So we taken only one phase, and here the neutral is taken as datum, so that's why usually single subscript notation is used for the phase voltage. And now if the load here load circuit is connected in delta, then it can be transformed in star using the delta star transformation. And when the load is balanced, the impedance of leg of the star is one third the magnitude of each leg, that we already seen in the previous slide from the delta to star transformation, as we given by zy is equal to z delta by 3, so that we already derived, and the circuit is modeled by the single phase equivalent circuit. So this is how we can do the per phase analysis. Now if you have further doubt and query in this topic, then feel free to contact me, and you can WhatsApp me and you can call me. So these are the assignment question for this particular chapter, so please note it down. And the instructions related to this assignment is given below. The questions are: what do you mean by the balanced three phase load and source? Explain the necessity of star delta and delta star transformation, also derive with its suitable expression, and what do you mean by per phase analysis? So after this presentation, if you have any doubt and query, please meet me into the doubt solving session. Thank you very much, students. Thank you all. Jai Swaminarayan.